For our Geometry Unit 2, we're going to be looking at triangle proofs. A proof is something where we try to build a larger understanding based on things we already know, based on assumptions, and then building more and more detailed understanding. So we're going to look at some of those things. First thing is, whenever you're trying to prove something to be true, you have to start with some assumptions, some things that you can just kind of take for granted, and we call those postulates. So for instance, we have a linear pair postulate that says if we have two angles that if you put them together they make a straight line, like angle 1 and angle 2 here, we call those a linear pair. And the linear pair postulate says that they are supplementary. The definition of supplementary is that they add to 180 degrees. So they might be 90 plus 90, or 100 plus 80, or 178 plus 2. It really doesn't matter, as long as they add to 180. Okay, so if angles 1 and 2 form a linear pair, we can say that they're supplementary, and that means that the measure of angle 1, which we write as this m angle 1, m stands for measure, that means how big it is. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. And that's something that we can just take for granted, and we can use it to build to larger understandings. So for instance, the vertical angle congruence theorem. Now, a theorem is something we have to prove. Vertical angles are any angles across from each other when two straight lines intersect. So this angle and this angle are vertical angles, but it has nothing to do with vertical versus horizontal. These two are vertical angles. It just means the two angles across from each other in the intersection. So we just want to prove that pairs of angles like that are congruent. By the way, this sign, the equal sign with the squiggly, means congruent, which you can kind of take as a geometry word for equal size. Okay, so we're going to start with what we know. We're told the angles 4 and 3 are vertical angles. So I'm going to write that down. Angle 4 and angle 3 are vertical angles. And that's something we're given. In other words, it's something we were told to start with. Okay? We can tell by looking at the picture that we have a straight line here. So angles 4 and 2 are a linear pair, just by the definition of a linear pair. They make a straight line. Okay, well, we can also see that angles 2 and 3 are a linear pair. So, like that. That is also a straight line. So again, angle 2 and 3 are a linear pair. I'm going to have to abbreviate here. All right. Because angle 2 and 4 are a linear pair, we know that they are supplementary by the linear pair postulate. And we know that angle 2 and angle 3 are supplementary. Okay, if they're supplementary, then they must add up to 180. So we can say measure of angle 2 plus measure of angle 4 equals 180 degrees by the definition of supplementary. By the same reasoning, we can say measure of angle 2 and measure of angle 3 add up to 180, again, by the definition of supplementary. Okay, I know this is substitution property, but I actually disagree with that. So I'm going to cross that off. I'm looking at these two lines, and I see the measure of angle 2 plus measure of angle 4 is 180, and so is measure of angle 2 plus measure of angle 3. So I'm going to say if they're both equal to 180, then they must be equal to each other. So measure of angle 2 plus measure of angle 3 is equal to measure of angle 2 plus measure of angle 4. And that's something called the transitive property. Transitive. Basically, if A is equal to B and B is equal to C, then A has to be equal to C. All right. Well then, if we have angle 2 plus 3 equal to angle 2 plus 4, we can subtract angle 2 from both sides. And that leaves us with measure of angle 3 equal to the measure of angle 4 by subtraction. Basically saying that you can subtract something from both sides of an equation and the result is still a valid equation. And we know that from the first unit in algebra. And then, if the measures of those two angles are the same, then angle 3 is congruent to angle 4, just by the definition of congruence.